Welcome back to my YouTube channel once again. Okay, so in this video we are going to discuss about Fermat's last theorem. Especially we will try to see whether we can prove Fermat's last theorem for n equal to 3. Okay, so Fermat's last theorem, in the previous videos we have proven that for even powers c power p minus a power p is equal to b power p, if p is even, then we can write this as c power x whole square. Okay, so p is even greater than 2. Alright, so c power x whole square minus a power x whole square equal to b power x whole square. Okay, this is not possible because difference of two squares should be 2y square. So that means that 2y square cannot be square of something. So we don't have any integers which can satisfy this equation p square equal to 2p square. So we discussed all that in my previous video for the proof of n equal to 4. Okay, so we have p is equal to even greater than 2, c power x whole square minus a power x whole square is equal to p power x whole square. That should take a form of 2y square. Since we don't have any squares with the 2 multiplier, okay, so this is actually true for any even number if p is even. So now we have to prove for when p is odd. Okay, so we will try to prove for first odd number. Apart from 1, first odd number is 3. It's also prime. So since it is a prime, we can actually from the Fermat's little theorem, if c power p minus a power p is equal to b power p, if p is prime, okay, then we can write this as again previous video we have to refer Fermat's little theorem. If you see, if p is prime, c power p minus c equal to p into c1. Alright, the difference of this is p multiplier. So whatever that p multiplier is c1, we call it. So c power p is equal to pc1 minus c plus c. Similarly, if p is a prime, again a power p minus a, p into a1, a power p is equal to pa1 plus b power p again minus b is equal to pb1. That is also b power p is equal to pb1 plus p. Alright, so we can, if you substitute this in this, so we have pc1 plus p plus c minus pa1 plus a equal to p1 plus b. So pc1, take the p terms this side, pc1 minus pa1 minus pb1 equal to a plus b minus c. So p equal to a plus b minus c, c1 minus a1 minus b1. That is actually, if you say k1, so p into k1 is equal to a plus b minus c. A plus b is equal to c plus b, pk1. Alright, so, and then take the case of when a plus b is equal to c. When a plus b is equal to c, a square plus b square is always less than c square, because when you square it, 2ab remains. 2ab is positive, so a square plus b square is less than c square. Okay, indirectly that means that when a square plus b square is equal to c square, a plus b is greater than c. Okay, so in this case we are trying to see whether it is cube, like 3. So if this is true, okay, a plus b must be greater than c. In fact, if this is true, a plus b is equal to c plus something. That something is actually p multiple. That means that this is holds good for whether p is equal to 3 or 5 or any of the prime, because Fermat's little theorem holds good for every prime. So that means that this is the generic equation. When c power b minus a power b is equal to b power b, then a plus b is equal to c plus p k1. K1 is this. Okay. So that means that we have to take this as one of the proofs. I mean, one of the carriers from this whole exercise. Alright, so okay. Alright, so now we have to see that. Alright, so now this is actually now becomes little interesting or little kind of a complicated. Okay, so now I write is c power p is equal to a power p plus b power p. Okay. Alright, there is a difference. Now with the p is odd prime. Except 2, every prime is odd. So I can write this as a plus b into a power p minus 1 minus a power p minus 1 b power p minus 2. Sorry, b a p power minus 1 plus b power p minus 1. Alright, in the case of c equal to 3, c cube is equal to a cube plus b cube, which is equal to a plus b into a square minus ab plus b square. Alright, I need to change my pen. So, yeah. So that means that we have generic equation c power p is equal to a plus b into something. So what we have seen is that a plus b, wow, this doesn't write even better. Okay, so I'll actually take this with a letter. Thank you.